The following presentation was recorded at the 2025 Southeast Linuxfest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information on the Southeast Linuxfest, visit www.southeastlinuxfest.org. Come join us next June.
Okay, good afternoon, everyone. This is good volume. Okay, bootable containers. I made some preparations for this so that you guys can see. I have demos. There is code that will be on the screen. If you need it, you can use the second link on the bottom and follow along on your phone. For people in the back, if you actually want to see the code, I mean, it should be readable, hopefully. But if you're having trouble reading it, you can follow along with that. This presentation also is downloadable on GitHub. All the code, everything running, all the demonstrations, it's on there. So you can not only see it, but look through the code used to generate it. So, okay. What is a bootable container? A bootable container is basically a standard container, but with the Linux kernel added to it. So you can, once you deploy a bootable container, there is no container runtime. I'm a little nervous, guys. First time doing it, so I got lost already. So a bootable container, I'm going to read a little bit off the slides until I get more comfortable. You can build, run, and push a bootable container just like a regular container. There's no difference. And then once it is deployed, there is no container runtime. It gets deployed as an immutable system. So this lets you fully build a VM image using container tools. This is an image that is borrowed from the Fedora project, but it basically shows you the life cycle of a bootable container. You can, starting with a container file, you can build, and then it can be deployed to a disk image or via a registry and pulled down for bare metal, edge devices, anything, VMs. So like I said earlier, if you're running a bootable container, it runs just like a normal container, but once it's deployed to a host, it becomes an immutable system. And if you guys aren't familiar, an immutable system separates user data from system data, and this allows the system to be updated or rolled back as a whole, and your data remains unchanged. The tool that enables this, the tool is the part that's kind of new, is called bootc. So after the deployment, bootc right now uses RPM OS tree in the background to manage the immutability. So if you've ever used Silverblue or uBlue or something like that, some of it will be familiar, but bootc is the new tool to manage this. This is just an excerpt from the bootc from the project page. It kind of just tells you about it. I'm not going to really read it, but the tool itself is what allows you to deploy and update and do rollbacks. So again, if you've ever used Silverblue, they didn't really have a tool. You just did like an RPM OS tree update or rollback, but bootc is specifically the new part. So I don't know. I wanted to pause, put some people to work. Does anybody have questions on this so far, or are we still too high level? Oh, yeah.
Quick general question.
Yep.
Why would I want a bootable container versus one that uses the host's kernel?
So if you, I mentioned it later, but if you run a bootable container, it doesn't use the host kernel. So that's probably, I should have kind of mentioned that. So when you run it as normal, it just uses the host container. It doesn't use the built-in one. So I don't know if I said it backwards. So yes, and then the reason to want one is that you can now have one container kind of to do all of it. So you can run it as a regular container or on the host. But why would you want it to be like a replacement for a regular container? Probably there's no reason to do that. So I don't know if that answers the question. Anybody else? The man in the front. Wait for the mic. Yep.
When a bootable container is running its own kernel module, how does it differ, or does it differ than how a VM works just in a VM state? If a VM's running on a host using its own kernel and everything built into it, how does that differ from a bootc container that is running its own kernel and everything running inside of it?
Kind of the same principle, except once it's deployed onto a system, it's not, there is no container left anymore. It just uses the kernel that was built into the container. So it's kind of the same, but a little bit different. I don't know, does that answer the question? Okay. All right. So a little bit, I probably should have went to this slide. Is my system a container now? This is when I try to explain this to people, this is a common misunderstanding. No. So once it's deployed, there's no more container runtime. The process of updating or managing the host is used with container tools to manage the image, but there is no more container itself. It's not running. And then maybe this answers the other question, but yes, it can be run and used as a normal container. Okay, so when you build a bootable container, the file system, well, using the bootc system, the file system is important. But when you're building the container, all of the files are writable just like you would expect them to be. So you can do anything in a container file that you would normally be able to do, edit or modify anything. So it's not immutable during the build process. But however, once it is deployed, it is now an immutable system, and only etc and var remain writable. The var is completely writable and persistent. There's nothing special about var. However, etc is a little bit different. So when you add or modify a file in etc, it will persist indefinitely, like how you modified it. Each rollback and update performs a three-way merge to combine changes from, I'm just going to read it from here, from the current environment, the default environment, and the new environment. So what this means is that the changes are actually part of the deployment. So if you make a change and you have a deployment and then you do a rollback, potentially the change will be lost because even though your change wasn't part of the image, the new container image, your change was staged in the current deployment. So I'm going to pause also. Is that confusing? I don't know if I said it backwards or it might be written a little bit better there, but we're going to, yeah. Yep.
So basically, on reboot, the only things that survive is the etc and the var.
Yeah, well, OS tree mounts everything as immutable, so you can't even change it. Unlike like a normal, I don't know if anyone's tinkered in a normal container where you can like get in, like exec in and then change files and then restart the container and the files are gone.
Yeah.
That doesn't, like with this, they're actually read-only. You can mount it read-write. I don't know what happens. Probably nothing good. But OS tree makes sure the rest of the file system is mounted read-only.
So bootc runs on a host OS, and then it basically creates a little virtual machine with its own kernel.
No, so
Is everything in there, or
once the container goes onto the host just acts like a regular host, but it's immutable now. So there's no container runtime. Bootc, at that point, bootc is just used for updates and rollbacks, but it's just to the host. The host has no container running on it.
Would bootc be like a different grub entry that you'd go into in order to update it, since it's booting?
Similar. It would have, like, when it would say on grub, like it's an OS tree based system. It might be a little confusing or hard or difficult to understand if you've never used Silverblue.
Yeah, I haven't used Silverblue yet. Okay.
But if you have more questions, let me know. Anybody else? I think we had two at least over here.
Okay, two of them. First of all, your example there is scary. You're saying that I could lose users out of the password file. And the second is, What about all my applications that I've gone ahead and put into opt and other things like that when you do the reboot? Are all your applications gone?
No, the applications are still there. This implication is mostly if during the build process, that could be where the sketchy part is. And this is not, I want to be clear, this is not a bootc thing. This isn't a RPM OS tree does it this way. And right now bootc uses that as the backend for the immutable part. So when I talk about this, like Silverblue and UBlue act like this already. So this is not really new. It's just me clarifying or maybe confusing people, me pointing it out. So a good example would be during the build process, if you are adding a package, maybe, I think Cockpit is one of them right now. If you add packages that require system users, maybe with certain UID numbers or whatever, and then, so that's during the build process. The build doesn't know anything. This is a fresh build, so it adds the users of the password file. And then when it runs on the system, like your actual deployed system, there might be a drift because you might already have that user, or maybe that user was removed, or maybe the UIDs were different. So this is really not that you're going to lose it, but maybe you're going to have issues adding packages with users later to the image.
So can you run multiple containers on the same host at the same time, or is it just one at a time?
It's one, and it's, to be clear, it definitely is not a container. Once it's deployed onto the system, it's not a container anymore. So yeah, no, you can only run one.
So then is this similar to something like Nix?
Similar to Nix, not in the way it's implemented, but in the same idea of like it's just an immutable system. After deployment, there's really no, the container part really doesn't matter other than when we're talking about building the images.
And when the guest is done, does it go back to the host OS?
No, because it's on the host. It is the host OS.
I see.
Yeah. Anybody else? We have one up front. Oh, you don't have it? Okay. Anybody else? Yeah, over here.
This is a bit of a silly question, but
Yep.
you said that once you boot up the container, it starts no longer a container. So can you run containers inside of it?
Oh, yeah.
Okay.
Yep. Just like a normal system. Anybody else? Okay. And these, again, if you downloaded the presentation or you take a picture of the slide, these articles describe this. The LWN one is brand new, like just as in a couple weeks ago, and it really describes this drift process. So if this was actually a Hello, there we go. Somebody asked to describe the drift process again. And I said, I don't want to confuse people. The LWN article has a much more in-depth, if that was an actual concern that you had, I would look there, honestly. But I had this process when adding Cockpit to an existing image. I already had an image. It was already deployed onto a system. I added Cockpit later, the front end, the GUI part, and that ended up breaking, and it was because of this drift thing. So again, I didn't lose any data or anything. It just like the image was not good anymore. I had to roll back, and yeah, so. Okay.
So basically, you should probably use Podman or something to add Cockpit to your container first.
I had that. No, you don't necessarily have to. Like when they figure this drift out, and again, this is not specific to bootc. This drift, Even Nix is mentioned in here. I know somebody mentioned Nix earlier. Nix has its own potential issues with drift that are just different. So. Okay, we're going to go ahead while I'm waiting on that. So Bootsy has a couple different deployment methods. The CLI these are just a few examples. The CLI can install to a disk, install to a file system, or install to an existing root. So that's an interesting one. We'll talk about that in a minute. But it also, right now, it works with Anaconda, and it works with the Bootsy image builder, which is another CLI tool. So right now, this is how Silverblue installs. If you can use Anaconda to deploy one of these images. Hello. Okay, looks like it's good. Thank you. Thanks, guys. Thanks. Okay. I don't know. I think that's been self-explanatory. So this is the part that is interesting to most people. So Bootsy install can actually take over an existing system. So if you weren't confused enough before, get ready for this. So you can actually use Bootsy to deploy one of these containers on top of a running system. And then once it's rebooted, the running system is no longer the one you had before, but it is now whatever image you just deployed. This trick really only works once. I don't think you can deploy on top of, you can't use this method to like take over another image, like another Bootsy install. But you can use this to take over a normal running system. And then I briefly mentioned it. There is another command that I don't think this ships with Bootsy, but the image builder, which can be used to create, and this was mentioned, I think, in the screenshot in slide 3. You can use it to create disk images or ISO files, like so VMDKs or ISOs. It was asked, so you can boot from a thumb drive. Yes, you can create an ISO that you can install from a thumb drive. No, the installer, and like it's a full install. So when you run it, it runs like the Anaconda, the GUI comes up and it just installs onto the system, just like if you were installing Fedora or CentOS Stream or something. Does anybody have any other questions? Okay.
So in terms of use cases, it's great for like bare metal system, doesn't have something already installed.
Who's got the mic? Yeah. It's going to be one of those, we're going to have to run it around.
I was saying one of the better, from what it sounds like, one of the better use cases for Bootsy is for systems that don't have anything running currently. It's like, you want to install something quickly onto a bare metal system. Bootsy is a great way to customize your system and push it out to this new bare metal.
That's one of the many ways that it could be used, yeah. Okay, so what does it look like to build one of these? Show of hands, anyone in here built a container before? We know what container files are? 50, 70%? Okay, so this hopefully is not too confusing, but this is just a very simple container build file or a container file, and we are going from the Fedora Bootsy image, and we're just installing Cowsay and Lolcat. So very simple, taking the base image, installing these 2 packages to it. And to build it, this is a podman build command, so just like you're building a regular container. So I'm tagging it with localhost bootsy test, and then we're pointing it at bootsy-test.container file. This is very similar, with or without Bootsy. This is how you would build a container. If you wanted a container to have lolcat in it, you would use the same thing, just maybe base it off not Bootsy, something else. So it has to be clear, it has to come from a Bootsy repository like this. A podman cannot create one of these. So it has to come from one that already is Bootsy, like one of the base ones. Rel calls this image mode. So you can pull from a Rel image mode, and CentOS Stream also has Bootsy. And I want to say Alma Linux has it too, but I don't know if I'm not Not sure on that, but I believe Alma Linux has bootc containers or bootc images. This is a quick demo of basically just the commands that we did or showed a minute ago, just for anyone to see the process happening. It looks very similar, again, if you were just building a regular container. You can see all that output from DNF, and then it's going to commit it, and then it's done. So just, again, like a regular container. I'm going to wait for it to finish. Okay, so again, just how it normally would look. Okay, so we're going to demo really quick running one of these containers, not deploying it, but just running it. So we're going to try to run Cause on the host, which doesn't have this installed. This is still a regular host, nothing deployed on it, nothing crazy. Regular host, it's missing this Cause package. So we're going to use the podman command to run it from our new bootc container, we're just demoing how these containers can be used as a regular container. So there it is on the host, not installed. And then we're going to look at our images. I can see we have our bootc test there. And there's the podman run command. And there it is, running right off the container, as you would expect from a normal container, normal podman usage. So this doozy of a command here, this is how you would deploy this on top of an existing system. So we talked about this, or I mentioned it briefly earlier. I won't go over all these options, but there are some important ones. You can see that on the lines for the volume there, we're linking the host dev devices to dev in the container. We're mapping varlib containers into varlib containers inside the running container, and we're mapping the entirety of slash into slash target. So we're giving this privileged container access to the host devices, the host disks, and the host podman runtime, and then access to the entire slash also. And then the bootc stuff's underneath. You can see where I'm going to just highlight it. This is where we're starting with the bootc stuff. So we're telling it to install 2-file system. We're skipping the fetch check. There's a check that will fail if it can't find your image. That's so that you don't deploy images that don't exist on the internet, but we're deploying a local image. So we're skipping the fetch check, and then we're replacing alongside a current system. The target is /target, loading in some SSH keys. We are pointing it to the local container host or container storage. Again, so we're not pointing to a repo on the internet or somewhere else. This is because we built the image locally. And then this is a flag you have to give, or else it doesn't know, or it will not destroy your system. So this is a newer one. So and I'm going to pause here for questions. The interesting thing here also is that we're running this from bootc test. That same image that we just built with Cause and lolcat has everything inside of it now to take over an existing system. So if you use this method, all you have to do is have one of these bootc containers, and you have everything inside of it that's needed to deploy this anywhere, but in this case, specifically on top of an existing system. Do we have any questions about any of that? I want to make sure I didn't lose anybody. Okay. So this is just a quick demo of what that looks like. You're going to see a lot of text, but I just wanted to show what it looks like. And I didn't want to do it live because some of these things take a while to run. Some of them don't, but you're going to easily eat up maybe 5 minutes doing something like this. So it checks the image, then it's saying we're going to deploy the image. and that's it. This was a little bit abridged. Like I said, probably expect 2 or 3 minutes, and then you reboot your system and it's gone. It's completely deployed now. So like I just said, once the installation is complete, you reboot it, it comes back up, you have a new host running this bootc immutable system. So I'm going to show just the demo, right, that we did earlier. Cowsay wasn't installed. Now we are post deployment. So we deployed a host now using our image. So our image has lolcat and Cowsay on it. So we should be able to run it straight from the command line now. And there it is. So this host is now running bootc. The operating system has been replaced, and with our image that we just put on. Does anybody have any questions before we go into updating? Okay. So updating is pretty simple, and I am going to pause here and say we're going to show updating with the one that we built. But if you are using a image from just upstream, like you could use just regular Fedora bootc or one of the other upstreams. You don't have to keep doing this build process. But we're building locally just to show you, like, this is how you do it. This is how you get your hands dirty with it. But if you didn't want to build, you didn't want to customize it, you could just pull down from Fedora or wherever else, rel image mode. They have a bunch of different, especially Fedora has a bunch of different versions. Like this is the base one that has minimal, but there's other ones, including Silverblue now runs this. So you can Silverblue. I don't know if bootc is in uBlue yet, but I know bootc is in Silverblue. So, but anyway, we're going to take our container file, the one that we built earlier. It had Fedora 41. This one has Fedora 42. So let's picture this. We have our host. We have an entire host, VM, whatever you want to call it. It's deployed with Fedora 41 using the bootc. And then in order to update it, we are building a new container with Fedora 42, and we are running another podman build command. And once that build command is done, we're going to run the update. Just a simple bootc update. And that works because bootc was installed with the local image. We specified it was a local image. So I'm building this new image as the same named local image. We got a question in the back.
Is the update in place? Does it require like a reboot, or
It does. It will require a reboot, just like other atomic systems. Yeah.
Is it like a hard reboot or just a reload?
No, it's a real reboot.
Oh.
Going down to metal and coming back up. We got a question up front. And I encourage the questions. I've done this. I demoed this at my work, and I got to the end and I lost like half the people. And that's maybe my presentation skills, but I think it's a simple tool, very powerful, but the concept, I believe, is complex to understand. So
Okay, so this is running inside of the one that
we've deployed
booted
it. Yes.
So this is in the deployed one
Mhm.
that's already running, and then you run this, and then you just run these commands, and then you just reboot, and then it works, right?
Yes.
Awesome.
Yes. And again, I wanted to say you don't have to build. We're building because I wanted to show you guys how to get your hands dirty, but you could literally, we could have installed it and pointed it at the upstream, the repo, like that repo that's there, and we wouldn't have to build. You could just do a bootc update, and it'll just pull down the newest image, and then you reboot, and you've got a new image. But I'm showing you, how to get your hands dirty, how to build your own. You could, in theory, do this in your own pipeline. If you don't have to do it manually on the box.
Since you're doing a hard reboot, are there any UEFI problems, or should there be some UEFI problems?
I haven't seen any. There hopefully shouldn't be. bootc has hooks into all that, just like a DNF does. So when it updates a system, it updates UEFI. It updates the stuff in /boot. So hopefully not.
Is it a security risk?
I'm not sure that I understand. How would it be a security difference versus a regular system, like any other system?
Well, with UEFI, I can go ahead and lock down the system and be sure that nobody can go ahead and change it. Now, in this case, you're going ahead and you're overriding the existing running system, and then with the reboot, it's running, or does the machine stop at that point?
Yeah, the machine, it's like a normal reboot, and then you go to, you'll pull up in Grub. I can't show you, I'm not going to be showing Grub here, but like once we do this, you would see Grub, and Grub would have 2 entries, and one would say Fedora OS tree Fedora 41, and the other one will say OS tree Fedora 42. So it's like just like a normal system update.
Okay, thank you.
Yep, like I said, I encourage the questions.
All right, so understanding reboots of this, they would pretty much just be other boot images, but other grub images if you wanted to roll back. Is that how you would?
Yeah, I cover that.
Like, same way you would a kernel now.
Yeah, I cover that a little bit later. And this is not specific for bootc. Silverblue does this. OS tree does this basically. But yeah, you get grub entries, and you can just select. Once we do this, if you wanted to roll back, you just select Fedora 41 at grub, and just boots in your old system.
Thank you.
Okay. So this is just a quick example of doing this. So bootc status shows us on Fedora 41. And then I'm just going to type out that container file. I'm going to time this. So I'm doing a build and a bootc update, and I'm wrapping it in a time just to kind of prove my point. This entire process of upgrading Fedora from 41 to 42, I'm going to spoil it. It takes 2 minutes and 9 seconds. I don't know if anyone here has updated Fedora server or desktop, but you can't update in 2 minutes and 9 seconds anywhere. Now, this is a base image, a minimal image, so that's cheating a little bit, but I seriously doubt that this time would be much longer even on, I mean, I know it's not because I use Silverblue. You pulled the new image down and you reboot, and it takes less than 5 minutes, which I think is incredible. But again, that's not specific to bootc, but 2 minutes and 9 seconds, and we have updated our distro from 41 to 42. And there it is, bragging about it. Okay. So this is another cool concept. I don't know if how other immutable systems do this, but so DNF right now, they do ship DNF on most of the bootc images. There has been talks of removing it, and we're not really going to get into that. But as of right now, DNF is on there. So if you do like a sudo DNF install, whatever, DNF will complain and say it's the system's read-only. You can't write to it. So you can use this command to temporarily make /user writable. It actually puts an overlay FS right on top. So if you run that command, it just mounts it right on top seamlessly, and you can do whatever the heck you want to do with /user. And that is transient, just like we had mentioned over here questions about rebooting. Yeah. So you doing this, user becomes completely ephemeral just for that run. Once you reboot, it goes back to the way that it was. So this is really quick. I don't know if anyone, running Silverblue, I've had a want to layer packages, but I don't want to wait for DNF and OS tree to do their thing to make, this is super quick. I'll show you. You run this command, it takes 2 seconds, install the package, do whatever you want, reboot, and it goes away, or just keep it there for a little bit. Oh, we got a question in the back.
Is this like mounted in RAM, and are you limited by RAM size for this, or no?
Nope. Oh, actually, are you talking about that? I don't know.
The user overlay, because otherwise
you might be. I don't know. That's a great question. I don't know the answer to that.
Okay, fair enough.
Yeah, I don't know. It might be. I'm not sure where it put. I guess just looking at mount after it's done, we might be able to see. So great question. I'll have to look into that. I don't know. Question in the back corner.
So why would you use bootc over Silverblue?
Silverblue now has bootc, so they're coming together basically. I don't talk for the project. The long-term goal is to not use OS tree, so I don't know how that's going to look. But the long-term strategy is bootc is the future of how Red Hat will be doing this. So I don't know if that answers the question, but yeah, it ships with it right now. So, okay, I'm going to show the overlay really quick. You run the command, you get that message. It's very clear. All changes will be discarded on a reboot, and then we just run the DNF command right there. And we don't have to, I don't know if anyone's done layering in here. Layering takes a while. It has to check the image out. It's got to do DNF on top of it. It takes a while. Again, this isn't a permanent solution, but if I just need to try this package really quick and I need it on the host for some reason, there you go, ASCII Querium. And that was not accelerated. That is real time. You run the command, you run DNF install, less than 20 or 30 seconds later, I got it working. So I don't know if anybody has any questions about that. No. Oh, we talked about rollback earlier, but here it is again, right? You can roll back from grub or from the running system. So bootc status shows you the current, we glimpsed at it earlier. It shows you where you're running, what the rollback is, and what the next stage version is. And bootc rollback just rolls us right back to the last image. It works virtually the same way that I think our PMOS tree rollback does the same thing. No, does a rollback cause a reboot? No. So it's staged, just like an update is staged. I'm seeing where I'm at in my slides, that we have some time. So yeah, on my systems, I mean, I guess, never mind. I mention it later. So we'll talk about updates and rebooting. So I'm just going to show this, but right, this is us showing that we're on Fedora 42. Bootc status shows that we are on Fedora 42. The rollback image is 41, and then I just run the rollback command. It thinks for a second, and it's done. So total time to roll back minus the reboot, 1 second. You just type the command in. Same thing on grub. If you're on grub, you just choose the rollback image, and then it just goes. So 2 seconds. Okay, so we've seen it, kind of seen it in action. Why would I use this other immutable systems? I believe the power to this is the fact that you can take your existing container knowledge, if you have it, and use it to now bake your own OS. I mean, it's not that hard. If you do Kickstart, you can make your own OS. I mean, you can't really update it from the Kickstart, but, and I know like NixOS we were talking about earlier, that involves learning, how to do that. I know that Nix has its own language. But this takes the knowledge you've already got, and you can apply it very simply, very easily. How, maybe it's not easy until you see how it works, but once you get going with it, it's like super, super quick, especially if you've done this before. And then, in a professional sense, now, like professionally in my day job, we use Packer and Terraform and Jenkins to make VMs. We make these images, and they got to be different for Azure. They got to be different for AWS. And they certainly don't even look like what the on-prem images look like, right? That's a whole different ballgame. But if you had your act together and you knew what you were doing as a company, right, you could use this system to make one image to do all of that. And even if the image couldn't do all that, you can now, just like how containers, you can base something from, you can have your containers based on another container. Well, the on-prem team could have an image that's based on the gold standard image. And now you have kind of like a chain of custody, because you can have, was it like SHA-256? You can check to make sure these files are actually legitimate, right, before basing it. So you have this like chain of custody where like the base image can be verified and we know what it is, and then we use that to build our special on-prem image or special Azure image, or this team needs a special image. And instead of like, let's say in the form of a team, they don't know anything, they just need these packages or whatever. They don't need to learn how the whole build process works. Just hand them the image all the way up to where they need it, and then they can have a container file that adds their packages, and there you go. And now they're not running some bespoke system or whatever, right? They're still running off corporate's image or whatever. And we're not talking about where we boot it up and change it. We're talking about it's changed during the build process. So I don't know if that was confusing or unclear. Does anyone have any questions about that? I got one right here.
It sounds like one of the primary applications, if not the primary application here, is the system update technique that you demonstrated. And I noticed you were mounting the host's root file system into target/target.
Yeah.
And so that led me to wonder what kind of file system operations are being performed during that update to completely destructively replace the /target? Is it something like an rsync delete?
I honestly do not know. This is so. I don't want to talk for the bootc project because I really don't know. But I do know that the system is moved into other folders, and it still persists. So I didn't want to cover that. I didn't cover it because it's a complex topic. But it still takes up disk space. So depending on how big the image you start or the host you started on, that could be a problem. They are currently working right now on cleaning that up. So
it sounds like there's a conceivable workflow where you are bootstrapping a system so that it's able to run the bootc container at a minimum, and then using that as a point of contact for an orchestration system to apply a certain version of an operating system via the bootc container.
Yeah, and they don't, right, the subsequent update doesn't have to be based on the old update, right? You can replace it. I didn't do it here, but in theory, you could go from like Stream to Fedora or something like that. I've done that. The only problem is the etc drift that we were talking about earlier. If CentOS or Fedora puts something different in etc, it's not going to have a good time when they flip over because it's going to stay persistent. But you could, in theory, do that. If you knew, like if you knew, you as the builder and deployer knew the consequences of that, you could bootstrap a simple system and then use it to deploy a more complex one. Yep. So I might breeze through some of this. I have Ansible automation to do this, but we are at 4 minutes. So I'm not going to show one of the slides, or maybe I will, I don't know, but it depends if people still have questions at the end. But I wanted to show, I have a project, I call it bootc Blade. It's an Ansible project that basically uses bootc and Ansible and bootc to deploy a Fedora KVM server. So wanted to show you like what, I guess maybe I'm going to show it, but this is what a container file would look like that has like a lot of stuff in it, like a real build, right? So don't expect you to actually read this, right? But you can see right here, like a bunch of DNF, like we're installing Podman, Fish, Ansible. Podman's probably already there. It's not needed, but Cockpit Bridge, Cockpit PCP. I'm not word wrapping, so you can't see everything, but we're allowing sudo stuff, man page fixes. We're setting the firewall. Again, this is on the base image. We're installing ZFS, right? That's a complex thing. And it is actually pretty complex because you have to figure out where the what the kernel is inside the container before you do the build. So that's fun. But again, so you can see how complex one of these build files can be, and then it'll spit out a KVM bootc system out the other side. So like that's available on this, and it's available in the presentation download, but this link here, you can actually see that file, not scrolling through it. But I'm going to go forward. So as an example, and I'm using bootc Blade, my project, as an example here, but this is an example for anybody that is rolling their own. Bootc has its own update system. It'll just update from whatever image you downloaded. But that wasn't good enough for me. I wanted it to actually build it, right? So I made the system, like the systemd service, to actually do the build we did earlier. So it will periodically hang on, highlight for you. It'll periodically, weekly, do the full rebuild. So in the case of our Fedora example with lolcat and cowsay, weekly, it would download the new Fedora image. It would do that up, install those two packages, and then it would do the bootc update. So in the background, weekly, my system will update. Now, it won't be effective until you reboot, but the system's just updating weekly. And this is like how Silverblue works. If you don't change it, it'll just update on its own. In this case, I'm, again, making a systemd unit file to actually do the build, which bootc doesn't do automatically. It has an update service, and it just wants to pull down from a repo. So I'm not going to show the Ansible automation because I think that we are out of time, basically. So, but I do have this slide here. I have Ansible automation. You can use as a reference. You can use it for your own stuff. But the Ansible automation, back to the bootstrapping, right? It'll bootstrap a host just by fill out the template, run it. It bootstraps the host, completely installs it, deploys it. When the system reboots, it will log in and configure the host. So again, nothing special to what I did, but I'm just showing you too can do this, right? So, And I want to know if anybody has any other questions. Or if we hopefully answered everything. Okay, there you go. Like I said, you can download the presentation if you wanted to see any of that stuff again. Yes, we got a question. The question is, can you use the graphical? Yeah, I mean, that's how Silverblue works right now. Yes, you could certainly do that. And you can make your own distribution like that. And Fedora, and I think some of the others, it ships with, it has images that already have the GUI in it, but you can install it just like how you would with DNF. So yeah. Mm-hmm. Yeah, you can completely customize it. So, okay, cool. That's what I got. And I think we're at time anyway, so. Thank you. Thank you.